In the permafrost of northeastern Siberia, miners have pulled mammoths from the ice. Not bones, not impressions, mammoths, soft tissue intact, eyes still in their sockets, and inside their stomachs, still undigested, buttercups, a wild grass, a small flowering plant called ranunculus that only blooms in temperate, sunlit conditions. These animals were grazing. One moment, they were standing on an open steppe under a blue sky, pulling flowers up by the root. The next moment, they were sealed into cold sediment so completely, so finally, that the digestive enzymes in their own stomachs never finished breaking down the food they had just eaten. The flowers are still there, recognizable, after 10,000 years. That detail, a buttercup preserved in the gut of a frozen mammoth, is one of the most quietly disturbing pieces of physical evidence we have about how fast the world can change. Not slowly, not with warning, without a single moment of preparation. And it is not a mystery in isolation. It is one data point inside a much larger, much darker pattern. The Earth has a history of these moments, sudden, total, indifferent. Events that have drained seas and raised them. Events that have dismantled languages, swallowed coastlines whole, and on at least one occasion, reduced the entire human species to a population small enough to fit inside a single sports stadium. Everything you have ever been taught about ancient history fits inside the last 5,000 years. The Earth is 4.5 billion years old. Between those two numbers is a vast and mostly silent archive. Worlds that rose and were dismantled before anyone alive could write a single word about them. People who painted on cave walls, built monuments, told stories around fires, and then vanished so completely we do not even know what language they spoke. Tonight, across the next hour or so, we are going to walk through 10 of those events. The Mediterranean Sea was created by one of them. The pyramids of Egypt may exist only because of another. Civilization itself, every monument, every alphabet, every grain harvest ever harvested, was built on top of layers of forgotten ruin. And the final entry on this list, the one we will return to at the end, is the disaster that the International Commission on Stratigraphy formally designated in 2018 as the official boundary marker of the geological age we are currently living in. The age we live in is defined scientifically and on paper by the fact that it began when it stopped raining over an empire. Let that sit for a moment. We will get there. But first, we begin, as all honest accounts of the Earth must, with the water. Catastrophe 10, the Zanclean Flood, 533 million years ago. Before there were people, before there were even early hominids walking upright in the East African Rift Valley, there was a hole in the ground the size of Western Europe. 6 million years ago, the geological plates of Africa and Eurasia were grinding into each other along a fault line running through what is now southern Spain and northern Morocco. The Strait of Gibraltar, that narrow channel where the Atlantic now pours into the Mediterranean, had sealed shut. Tectonic uplift had closed the gateway. Once the Atlantic was cut off, the basin behind it began to disappear. What happened next is called the Messinian Salinity Crisis, and it remains one of the strangest events in the planet's entire geological history. Cut off from oceanic resupply, surrounded by some of the most evaporation-prone latitudes on Earth, the Mediterranean simply began to dry out. The water went into the sky. Salt precipitated and settled. Layers of evaporite minerals built up across the basin floor, in some places hundreds of meters thick. The shoreline retreated and kept retreating. Over hundreds of thousands of years, a sea became a chain of hypersaline lagoons, then salt flats, then a near-empty depression sitting almost 5 kilometers below the level of the surrounding continental shelves. 5 kilometers of vertical drop with nothing in between except baked salt, exposed sediment, and air so dense and so hot that anything resembling complex life would have been suffocated by the pressure alone. Temperatures at the lowest points have been modeled at over 80 degrees Celsius during summer. This was not a sea. It was an inverted mountain range full of nothing. An arid hellscape lower than Death Valley by an order of magnitude, larger than the Sahara, ringed by the mountains that would eventually become the coastlines of Italy, France, Spain, North Africa, Greece, Turkey, and the Levant. And then, the wall holding back the Atlantic gave way. In December 2024, a research team led by Dr. Aaron McAuliffe published a study in the journal Communications, Earth and Environment, based on detailed subsea surveys of the Sicily Sill, the underwater ridge between Sicily and North Africa that the floodwaters had to overtop on their way east. What the team found, etched into the bedrock beneath the modern seabed, was a field of more than 300 elongated ridges, all aligned in the same direction, all consistent with erosion by a fluid moving at extraordinary speed. The estimated flow velocity from the ridge dimensions reached 32 meters per second, a sustained flow rate beyond anything documented in any modern river flood. The peak flow rate of the Zanclean megaflood has been estimated at between 68 and 100 million cubic meters of water per second. The Amazon River, the largest river on Earth today, discharges around 200,000 cubic meters per second at its mouth. At its peak intensity, the Zanclean flood was several hundred times the volume of the Amazon, pushed through a corridor narrow enough to walk across in a single afternoon. The most aggressive models, supported by the ridge evidence, suggest the entire Mediterranean basin filled in somewhere between 2 and 16 years. During the peak of the inflow, water levels in the deepest sections would have risen by more than 10 meters per day. A shoreline could retreat backward, away from the approaching water, faster than a person could walk. There were no humans alive to see this. There would not be humans for 5 million years. But consider what was lost and what was given. The world that existed before the Zanclean flood, that deep, dry, salt-rusted hole between 2 continents, is gone in a way that no human eye ever saw and no human language can quite describe. The Phoenicians sailed across the Mediterranean without knowing it had ever been anything else. The Greeks colonized its shores. The Romans called it Mare Nostrum, our sea, as if it had always been there, waiting for them. It had not always been there. Every map of the Mediterranean ever drawn is a map of the aftermath. The trade routes, the coastlines, the entire stage on which classical civilization performed, all of it was set by a catastrophe our species missed by an unimaginable margin. The land became the sea, a footnote worth carrying forward as we go. Most of the events on this list were unknown to science until the second half of the 20th century. The Zanclean flood was only definitively identified in the 1970s. The strongest physical evidence for its violence was published in 2024. The catalog of catastrophes we are walking through tonight is, in a very real sense, still being assembled. Future research will add to it. The version of this list that exists 50 years from now will not be identical to the one you are hearing right now. Catastrophe 9. The Toba super eruption, 74,000 years ago. If you fly over the northern part of the Indonesian island of Sumatra and look down, you will see a long blue lake set into a high plateau. About 100 kilometers long, 30 kilometers wide, large enough to be visible from low Earth orbit. There is a smaller island sitting roughly in the center, the resurgent dome, the slow regrowth of the magma chamber underneath, building toward what will eventually be the next eruption. What you are looking at when you look at Lake Toba is the throat of one of the most violent volcanic events the Earth has produced in the entire span of human existence. The volcanic explosivity index runs from 0 to 8. The 1980 eruption of Mount St. Helens, which flattened forests across hundreds of square kilometers, was a 5. Krakatoa in 1883, whose detonation was reportedly heard 4,000 kilometers away across the Indian Ocean, was a 6. Mount Tambora in 1815, which caused the year without a summer and led to crop failures across Europe and North America, was a 7. Toba, approximately 74,000 years ago, was an 8, the maximum classification on the scale. Each step represents roughly a 10-fold increase in erupted volume. Toba was at least 1,000 times more powerful than Mount St. Helens. The total ejected material is currently estimated at between 2,800 and 5,000 cubic kilometers. The atmosphere over much of the planet was loaded with pulverized rock, ash, sulfur dioxide, pumice, and glass shards on a scale unmatched in the entire span of human evolution. Ash from the eruption has been found in marine sediment cores in the Indian Ocean, in the South China Sea, in lake sediments as far west as Lake Malawi in East Africa, more than 7,000 kilometers from the source vent. Across the Indian subcontinent, geologists have identified an ash layer averaging around 5 centimeters thick, with localized deposits running up to 15 centimeters. Volcanic debris blanketing the entire region from the modern Pakistan border to the Bay of Bengal. And this is where the human story enters. There is a peculiar fact about our species that geneticists have known for some time and that population biologists find genuinely puzzling. The genetic diversity of all 8 billion people alive on Earth today is extraordinarily, almost suspiciously, low compared to other large mammals. Chimpanzees living in a single forest in Central Africa contain more genetic variation in their DNA than the entire current global human population. A few troops of chimps in Côte d'Ivoire are genetically more diverse than every person you have ever met, combined. This is not normal. A species that has spread across every continent and reached a population in the billions should, by every rule of population biology, contain enormous internal variation. We do not. Our DNA strongly suggests that at some point in our past, our entire breeding population was reduced to a very small number, and every modern human alive today descends from that small group of survivors. This is called a genetic bottleneck. In 1998, an anthropologist named Stanley Ambrose at the University of Illinois put forward a hypothesis. The bottleneck and the Toba eruption were the same event. The reasoning was direct. The eruption would have injected enormous quantities of sulfur dioxide and fine ash into the stratosphere. That material would have stayed aloft for years, blocking incoming solar radiation. Global temperatures would have dropped by an estimated 3 to 5 degrees Celsius for years, possibly decades. In higher latitudes, regional cooling may have reached 15 degrees. Some models suggest a full volcanic winter. For a human population already small to begin with, scattered bands of hunter-gatherers in Africa and the Middle East, entirely dependent on local plant and animal availability, this would have been catastrophic. Ambrose's estimate was that the global human breeding population at the bottom of the bottleneck may have fallen to between 3,000 and 10,000 individuals. Every person alive today, on this hypothesis, descends from a population small enough to fit inside a single modern sports stadium. The hypothesis is contested. More recent archaeological work, particularly at sites in southern India, where artifacts have been recovered both above and below the Toba ash layer, has shown that some human populations apparently continued through the eruption. Not all the genetic evidence aligns perfectly with the Toba timing. There are researchers who now argue the climate effect was milder than originally proposed. What is not contested is the eruption itself. The volcano detonated. Thousands of cubic kilometers of material went up. Hemispheric ash deposition is in the rock record. And something, perhaps Toba, perhaps not, but something did push our entire species through a population bottleneck so severe it still shows up in our DNA 70,000 years later. Consider for a moment what survival through a volcanic winter at this scale would have actually looked like for the bands that made it through. Their hunting grounds altered overnight. Familiar plants no longer producing edible fruits at familiar times. Migration patterns of large game disrupted as the animals moved to track shifting vegetation zones. Water sources contaminated by ash fall for weeks or months. Skies dim enough during peak ash loading that even at midday the sun would have appeared as a weak red disk behind permanent haze. Children would die first. Elders who carry the accumulated practical knowledge that hunter-gatherer societies depend on would die second. The tool-making traditions, the seasonal calendars, the medicinal plant knowledge, the burial practices, the names for everything in the surrounding landscape. All of that lived in the heads of specific people. When those people died young and unexpectedly, what they knew died with them. If Toba did push our species through a bottleneck of 3 to 10,000 individuals, what survived was not just genetic, it was a curated, incomplete subset of everything that human bands across Africa, Asia, and the Levant had developed during the preceding 150,000 years. We are the descendants of a filter event. Most of what came before us, culturally, behaviorally, did not make it through. We almost went out completely. Most of us never came back. Catastrophe 8. The Flooding of Doggerland. 8 to 5,500 years ago. There is a region on the floor of the North Sea, between the eastern coast of England and the western coast of the Netherlands, where fishing trawlers occasionally pull up something that does not belong in a fishing net. Mammoth tusks, stone tools, pieces of carved bone. A barbed antler harpoon, fully fashioned, dating to somewhere between 6,000 and 12,000 years ago. In one famous case in 1931, a trawler called the Colinda dredged up a complete worked antler point from a depth where no antler should ever have been. The discovery confirmed something that geologists had already suspected from the seabed contours. The North Sea, in its current form, is younger than human civilization, and it used to be land. During the last glacial maximum, 20,000 years ago, so much of the world's water was locked up in continental ice sheets that global sea levels were approximately 120 meters lower than they are today. The English Channel did not exist. Britain was not an island. The shallow continental shelf that now lies beneath the North Sea was instead an enormous lowland plain, stretching from what is now eastern England all the way across to Denmark, the Netherlands, and northern Germany. This place has a name. Archaeologists call it Doggerland, after the Dogger Bank, a shallow ridge in the middle of the modern North Sea where the highest hills of the lost country once stood. It was not a wasteland. By the early Holocene, as the ice retreated and the climate warmed, Doggerland was one of the most productive places in northern Europe. Salt marshes along its coasts, reed beds in its river deltas, forested uplands, lakes, estuaries, game in extraordinary abundance, red deer, aurochs, wild boar, beaver, salmon, sturgeon. Mesolithic hunter-gatherer communities lived here for thousands of years, working flint, fishing the rivers, building seasonal camps, raising children, burying their dead. In 2007, an archaeologist named Vince Gaffney at the University of Birmingham obtained access to oil and gas industry seismic survey data, the same three-dimensional seabed scans that energy companies use to find petroleum deposits, and used them to reconstruct the topography of Doggerland in extraordinary detail. What emerged from that data was a map of a country, major rivers, including a now-vanished tributary system that flowed northeast into a large freshwater basin in the central North Sea, estuaries, marshes, hills, a territory roughly the size of modern Britain itself, fully mapped, fully imaginable, and entirely underwater. Whatever Doggerland was, it had been continuously inhabited across multiple human populations for tens of thousands of years before the water came. The drowning was not a single event. It was a process that lasted thousands of years, and that the people inside it experienced as a slow, ongoing emergency. Beginning around 8,500 BC, as the great ice sheets continued to melt and sea levels rose, the edges of Doggerland began to fail first. Low coastal areas flooded, salt marshes turned permanently salty, river mouths backed up, communities living at the margins moved inland, generation by generation, as the world they knew got smaller. The pace was not even. There were periods of rapid sea level rise and periods of relative stability, but the overall direction was one way only. The land was getting smaller, the water was getting closer. By around 6,500 BC, Doggerland had been reduced to an archipelago. The highest ground, the Dogger Bank, still stood as a substantial island, possibly comparable in size to modern Sicily. The communities still living on these islands had been there for generations. Their ancestors had lived on a continent. Now they lived on shrinking territory, surrounded on every side by water that had advanced within living memory. What was lost is incalculable. An entire continent's worth of human history, potentially spanning 5,000 years of continuous habitation. The language those people spoke is gone. We do not have a single word of it. The names they gave to their rivers, their hills, their settlements, their gods, their dead, all gone. The oral traditions, the burial customs, the cosmological stories about how the world began, all swallowed by the ocean. Their cemeteries are at the bottom of the North Sea. Their seasonal camps are submerged. the places where they buried their grandparents and ground their grain and built their final winter shelters before the water came over the doorway, all underwater, all silent, all waiting. And the drowning, when it ended, did not end gently. The final blow came from the north, and it was not the slow rise of the sea that delivered it. Catastrophe 7. The Storegga Slide. 8,150 years ago, about 300 kilometers off the western coast of Norway, in a section of the Norwegian continental shelf that geologists now call the Storegga area. The name means the Great Edge in Norwegian. Something failed beneath the ocean approximately 8,150 years ago. What failed was not a small failure. A block of seabed, roughly 300 kilometers long, 50 kilometers wide, and several hundred meters thick, an area of solid sediment about the size of Scotland, broke loose from the continental shelf and slid down into the deep ocean. The volume of material involved, an estimated 3,500 cubic kilometers of sediment, moving in a matter of minutes. It remains one of the largest known submarine landslides ever recorded in the Earth's geological history. What triggered it is still being investigated. The most widely accepted explanation involves a combination of factors that aligned in a specific window: accumulated post-glacial sediment loading, the destabilizing release of gas hydrates as ocean temperatures shifted, and possibly seismic activity from the rebounding Scandinavian landmass as it rose back up after being pressed down by the weight of the recently melted ice sheet. The slope failed because the conditions for stability had drifted just past a critical threshold. The seabed gave way. Submarine landslides of this magnitude do not announce themselves. There is no atmospheric warning, no earthquake powerful enough that people living on distant coastlines would have felt it through their feet. The trigger may have been imperceptible to anyone not directly above it. When that much sediment displaces that much water that quickly, the result is a tsunami, not a wave in the ordinary sense, a wave train. A series of pulses of displaced water moved outward across the North Atlantic in every direction, traveling at the speed of a commercial aircraft. Modern modeling, calibrated against the actual deposit record, suggests the first wave reached the Shetland Islands within approximately 3 hours of the initial slide. The geological evidence for what happened when those waves hit land is extraordinary, and it is preserved across the coastlines of northern Europe. On the Shetland Islands north of mainland Scotland, sediment scientists have traced wave deposits to elevations of more than 20 meters above the sea level of the time. Sand and marine debris lifted to that height by water. Along the northeast coast of Scotland, tsunami deposits register at elevations of around 3 to 6 meters above contemporary sea level, with sand layers traced as far as roughly 80 kilometers inland, in places where the wave funneled up estuaries. On the Norwegian coast itself, the side facing the slide directly, reconstructions estimate tsunami deposits at elevations of roughly 10 to 12 meters above the sea level of the time, with some modeling suggesting locally higher run-up where bays and fjords funneled the wave. The deposits are recorded in coastal peat bogs across western Norway, where a layer of marine sand and shells sits abruptly between layers of terrestrial vegetation, marking the moment when the ocean came up over the land and then receded, leaving its calling card behind in stratified form. Now consider the connection that ties this entry to the previous one. By the time the Storegga wave arrived, Doggerland had already been drowning for thousands of years. What remained of it was a low-lying archipelago of islands and shallows, the highest ground sitting perhaps 30 or 40 meters above the surrounding sea. Imagine the geometry of what happened. You are standing on a low coastal flat, perhaps 2 or 3 meters above the tide. You see, far out on the horizon, the sea begin to do something it has never done before. It withdraws. The tide line retreats out beyond the limit of vision. Fish flop on freshly exposed mud. Whatever survival instincts a 30,000-year cultural memory of coastlines has produced, you have those instincts. You do not have a word for tsunami. You do not have a written record of any previous one. You are looking at something your grandfather's grandfather never saw and never described. Then it returns, not as a tide, as a wall. For any people who were standing on what remained of Doggerland in that moment, there was no high ground left to run to. The slow drowning of their continent had eliminated the mountains and the hills. A wave of that magnitude, crossing a place whose highest natural elevation was perhaps a few tens of meters above sea level, would have moved across it in minutes. A continent's worth of forgotten history, still down there, still being slowly recovered from beneath the North Sea floor. Catastrophe 6, the Black Sea Deluge, 7,600 years ago. Somewhere down in the cold, almost completely oxygen-free deep water of the modern Black Sea, more than 150 meters below the surface, the bones of a freshwater lake are preserved in conditions that should not exist anywhere else on Earth. Wooden structures, tool fragments, shells of mollusks that cannot survive in saltwater and have not lived in this basin for more than 7,000 years. A complete fossil shoreline, intact, undisturbed, sitting at a depth where the modern Black Sea is salt, and the modern world has long since forgotten that any of this was ever above water. The Black Sea, in its current form, is approximately 7,600 years old. Before that, it was something else entirely. In 1997, two geologists at Columbia University, William Ryan and Walter Pittman, proposed a hypothesis that would become one of the most discussed and most contested theories in late 20th century Earth science. Their argument, supported by sediment cores, sonar surveys, and radiocarbon dating, was that the modern Black Sea was created by a sudden and catastrophic flood that broke through the natural land barrier at what is now the Bosphorus Strait, pouring salt water from the Mediterranean into what had been for tens of thousands of years a much smaller, much lower freshwater lake. The mechanics of their proposed event were extreme. The pre-deluge lake sat approximately 150 meters below modern sea level. As global sea levels continued to rise after the end of the last ice age, the Mediterranean climbed steadily higher relative to the Black Sea basin. The rising Mediterranean topped the natural sill at the Bosphorus and began to spill over. Once the spillover began, erosion of the narrow channel accelerated dramatically. The trickle became a cascade. The cascade became a roar. At peak flow, according to Ryan and Pittman's modeling, the Bosphorus deluge would have been moving approximately 200 times the discharge of Niagara Falls. The lake surface rose by as much as 15 centimeters per day in the early phases. The flat northern shorelines retreated at rates exceeding a kilometer per day. Within months, an area of fertile land, roughly the size of modern Ireland, was submerged. Within years, the entire lake had risen by over 100 meters. Salinity had reversed completely, and the freshwater ecosystem that had existed in the basin for millennia was dead. What this means is sobering. The submerged shoreline of the pre-deluge lake is, in effect, an enormous archaeological preserve. It has barely been explored. Most of what is down there has never been touched by modern science. Whatever communities lived on the old shore, whatever they built, whatever they left behind in the final weeks and days before the water rose, much of it may still be there, waiting. What is not in dispute is that people lived on the old shoreline. The land surrounding a freshwater lake in a semi-arid region with reliable annual precipitation and rich alluvial soils would have been some of the most desirable agricultural territory in all of Neolithic Eurasia. The communities living there were not nomadic hunter-gatherers passing through. They were among the earliest farmers in the world. They cultivated wheat and barley. They raised sheep and goats. They built permanent structures. Then the water came. Across the broader region, through Mesopotamia, Anatolia, the Levant, the Caucasus, almost every ancient mythology contains a flood story. The Epic of Gilgamesh has one. The Book of Genesis has one. The Greek myth of Deucalion has one. The Mesopotamian Atrahasis epic has one. They are not identical, but they share remarkable structural similarities. A human community destroyed by rising water, a few survivors who escape, a world afterward that is fundamentally different from the world before. Some researchers have argued, and the argument remains controversial, that these flood myths may preserve in highly mythologized and theologically reframed form the cultural memory of the Black Sea deluge. The communities displaced by the rising water would have scattered across the surrounding region, carrying their stories with them. Over generations, those stories could have been reworked, embellished, attached to local deities, transformed, eventually, into religious texts. Whether or not the Mesopotamian and Hebrew and Greek flood traditions actually preserve a memory of the Black Sea event specifically, that question may never be resolvable with certainty. But the underlying possibility is, on the evidence, not fanciful. The flood happened. People lived through it, or escaped it, or died in it. The stories may be theirs. An entire shoreline of early agricultural Europe, now sitting in oxygen-free darkness, waiting to be found. Catastrophe 5. The Younger Dryas. 12,800 years ago, return for a moment to the mammoths in the Siberian ice. The ones with buttercups still in their stomachs. Those animals did not die slowly. They did not starve. The leading scientific explanation, based on broken bones and suffocation signatures found in several recovered specimens, is that they fell into crevasses or were caught in collapsing banks of frozen mud and were buried so rapidly in cold sediment that the wild flowers in their guts never had time to break down. The preservation does not require an instantaneous hemispheric flash freeze. What it does require is a Pleistocene environment structurally different from anything you would find on the modern Siberian steppe. A place where large animals routinely grazed in latitudes and ecosystems that no longer support them, ending up frozen into ground that has now held them for tens of thousands of years. And that environment did not last. Around the time those mammoths were grazing, the Earth was lurching out of the last ice age and into the climate of the modern Holocene. The transition was not smooth. At one point in the middle of it, the warming stopped and reversed. The reversal is called the Younger Dryas, named after a small alpine flower, Dryas octopetala, whose pollen appears in northern European sediment layers at exactly this period, indicating a sudden cold climate vegetation regime, replacing the warmer forests that had been spreading northward as the Ice Age waned. By 13,000 years ago, the world was warming. The great Pleistocene ice sheets were retreating. Sea levels were rising. Temperate forests were recolonizing latitudes that had been tundra a few thousand years earlier. Megafauna populations across Eurasia and the Americas were under pressure from a combination of climate change and the spreading human population. But many species were still hanging on. North America still had mammoths, mastodons, giant ground sloths, short-faced bears, dire wolves, saber-toothed cats, giant beavers, and a megafauna assemblage that would have looked to a modern eye like the African savanna on steroids. Then, within years, possibly within a single year in the most rapidly responding records, the warming stopped. Temperatures in Greenland fell by approximately 10 degrees. The North Atlantic froze further south than it had in millennia. The cold reached deep into Europe, into North Africa, into the Levant, and across to North America. Vegetation zones snapped backward. Forest died. Open tundra returned to areas that had been temperate forest within a single human lifetime. And during this period in North America, something happened to the megafauna that biologists and paleontologists are still trying to fully explain. 35 genera of large mammals vanished from the continent within a few thousand years, bracketing the Younger Dryas. Mammoths, mastodons, glyptodonts, dire wolves, short-faced bears, camels, yes, camels, which evolved in North America before going extinct on their home continent, surviving only as dispersed descendants in Asia and South America. Horses similarly evolved in North America and went extinct there during this period, surviving only in Eurasian populations that would not return to the Americas until the Spanish brought them back 15,000 years later. At the same time, the Clovis culture, the earliest widely confirmed and widely distributed human culture in the Americas, named for the distinctive fluted spear points first identified in Clovis, New Mexico, disappeared from the archaeological record. The same tool-making tradition that had spread across the continent over the previous several hundred years simply stopped. This is a triple coincidence in time. The climate crashed, the megafauna died, the leading human culture vanished, all within the same approximate window. The Younger Dryas itself lasted roughly 1,200 years. Then it ended. And the ending was, if anything, even more abrupt than the beginning. Ice core records from Greenland suggest the climate transitioned from full Younger Dryas cold to full Holocene warm in as little as 40 to 50 years. A generation that had spent its childhood shivering through bitter winters could have lived to see its grandchildren growing up in a climate roughly comparable to today's. What caused it? Two leading explanations remain in active scientific debate. The first is the meltwater pulse hypothesis. An enormous proglacial lake called Lake Agassiz, dammed by ice, catastrophically drained into the North Atlantic, disrupting the oceanic conveyor belt that distributes heat from the tropics to the northern high latitudes, and plunging the northern hemisphere back toward glacial conditions almost overnight. The second is a comet impact hypothesis, published in 2007 and still contested, that proposed fragmenting cometary debris struck the northern hemisphere at the onset of the Younger Dryas. The mainstream scientific reception has, on balance, remained skeptical of the impact hypothesis. The meltwater pulse mechanism remains the more widely accepted explanation. What is established is the timing. Whatever caused the Younger Dryas, it began suddenly, lasted approximately 12 centuries, ended even more suddenly, and coincided with the disappearance of the dominant human culture in the Americas, and the extinction of dozens of large mammal species across the same continent. And one more thing. Almost exactly as the Younger Dryas ended, in southeastern Anatolia, on a hill that the modern Turkish locals call Göbekli Tepe, Potbelly Hill, construction began on a series of monumental stone structures that should not, by every model of prehistoric human development that existed before their discovery, have been possible. T-shaped limestone pillars up to 5.5 meters tall, some weighing as much as 20 tons, arranged in interlocking circles, carved with detailed reliefs of animals, foxes, scorpions, snakes, vultures, lions, wild boars, 7,000 years older than Stonehenge. Built, according to the conventional archaeological timeline of the region, by people who had not yet invented agriculture, by hunter-gatherers. The discovery of Göbekli Tepe, beginning with the first excavations by Klaus Schmidt in 1995, fundamentally rewrote what we thought we knew about the cognitive and organizational capacity of late Pleistocene humans. How does a society of hunter-gatherers, in the immediate aftermath of a 1,200-year climate catastrophe, organize the labor and the knowledge required to quarry, transport, and erect 20-ton carved monoliths? Why did they do it? What did the carvings mean? Were they responding to something? The memory of the cold years, the loss of the megafauna, the trauma of the climate event itself? We do not know. What we can say is this: Göbekli Tepe and a small handful of related sites in southeastern Anatolia form a regional architectural tradition that predates every other known monumental construction site on Earth. The Egyptian pyramids are 7,000 years younger. Stonehenge is 7,000 years younger. The ziggurats of Mesopotamia are 6,000 years younger. A climate catastrophe, the disappearance of the first North American culture, the extinction of a continent's megafauna, and the unexplained sudden appearance of monumental architecture in Anatolia. All bracketing the same 1,200-year window in human prehistory. Catastrophe 4. The collapse of the Green Sahara, 5,000 to 3,000 years ago. If you took an airplane today across the Central Sahara, from the western coast of Mauritania to the Red Sea, you would fly over more than 4,000 kilometers of one of the most hostile environments on the planet. Sand seas, stone deserts, eroded plateaus. Annual rainfall in much of this region is less than 25 millimeters per year. In some places, it does not rain for years at a time. Temperatures during the day routinely exceed 50 degrees Celsius. 8,000 years ago, you would have flown over savanna grasslands, riverine forests, and, at the geographic center of what is now the Bilma Erg, a freshwater lake larger than Germany, the Sahara was green. It is the kind of statement that sounds metaphorical when you first hear it, but it is not. The pollen record, the lake sediment cores, the fossil pollen samples, the bone deposits, the rock art, every independent line of evidence converges on the same conclusion. During the African humid period, roughly from 12,000 to 5,000 years ago, the Sahara was not a desert. It was a productive, biodiverse, well-watered place, supporting some of the largest concentrations of wildlife on the planet. The centerpiece of the Green Sahara was a body of water now called Lake Megachad, the ancient precursor to the modern Lake Chad. At its maximum extent, approximately 7,000 years ago, Megachad covered an estimated 400,000 square kilometers, larger than the modern Caspian Sea, larger than the modern Great Lakes combined, a freshwater inland sea sitting in the middle of what is now one of the most arid places on Earth. The ancient shorelines of Mega-Chad are still visible in satellite imagery. Long, perfectly preserved beach ridges running across hundreds of kilometers of empty desert, marking sea levels from a world that has been gone for thousands of years. The wildlife was extraordinary. Hippopotamuses lived throughout the central Sahara. Crocodiles inhabited the rivers and lakes. Giraffes browsed in the woodlands. Elephants migrated across what is now bare rock and sand. Lions hunted gazelles in the grass. Across the Tassili Nayur Plateau in modern Algeria, ancient peoples painted what they saw. The rock art shows cattle herders driving their stock across grasslands, hunters with bows in pursuit of large game, dancers, swimmers, actual swimmers, in a painting now known as the Cave of Swimmers in southwestern Egypt, depicting people clearly swimming in open water. In a part of the Sahara that today receives less rain than the surface of Mars, people lived in the Sahara, not as nomadic herders passing through, but as residents of an inhabited place. The population of the Green Sahara, across its full extent, has been estimated conservatively in the millions. This was not a marginal frontier. This was, for several thousand years, one of the most populous regions of the African continent. And then, beginning around 5000 BC, the world they lived in started to die. The cause was astronomical at its root. The Earth's axial tilt and its orbital precession, slow, regular variations in the geometry of the planet's relationship to the Sun, were gradually shifting the strength and northern reach of the West African monsoon. The same forces that had earlier driven the African humid period now began to reverse it. The monsoon belt retreated southward. Annual rainfall in the central Sahara began to decline. If this had been a purely astronomical effect, the drying would have been very slow, almost imperceptible across human generations. But climate models suggest the system contained tipping points. As rainfall declined, vegetation began to die back. As vegetation died back, the land surface reflected more sunlight, absorbed less heat, and contributed less moisture to the atmosphere through transpiration. Reduced atmospheric moisture meant reduced rainfall. Reduced rainfall meant more vegetation loss. A feedback loop accelerated the drying, far beyond what orbital forcing alone would have predicted. The cattle herders moved south, into the still-watered Sahel and into the forests of West Africa. The fishing communities moved east. The hunters followed the game wherever it went. Whole linguistic and cultural traditions, built around places that no longer existed, fragmented and reformed, and were carried into new territories. But the migration that mattered most for the history of human civilization was the one that headed east, into the only place left in the region with a permanent and reliable water supply, the Nile Valley. This is where the story takes a remarkable turn. The Egyptologist Fakhri Hassan, along with a number of other researchers working on the desertification of the Sahara, has proposed that the influx of Saharan refugees into the Nile corridor during the late stages of the green-to-desert transition fundamentally changed the demographic and cultural character of the region. These were not displaced primitive people seeking shelter. They could be inferred to have arrived as experienced pastoralists, agriculturalists, and craftspeople, carrying with them millennia of accumulated knowledge about cattle, grain, water management, and social organization. When the Saharan migrants arrived in the Nile Valley, they encountered a place already populated by indigenous river communities. The interaction between these populations over centuries of contact, intermarriage, exchange, and cultural blending could have produced the demographic and technological conditions out of which Egyptian civilization eventually emerged. The first dynasty of Egypt rises around 3100 BC, conspicuously close to the end date of the Saharan desertification. The pyramids, the hieroglyphs, the pharaohs, the entire cultural legacy of ancient Egypt may exist, on this view, in significant part because a lake larger than Germany evaporated, and the refugees of an entire dying continent had to go somewhere. The Sahara is one of the only places on the planet where you can stand on bare rock and look at painted images of the wildlife that used to live where you're standing, knowing that the water and the grass and the game and the human communities are all gone. None of it because of any single catastrophe, because the climate slowly, quietly killed it. The rock art is the autobiography of a vanished world, an entire continent's worth of inhabited grassland, dried into dust, its survivors carrying their knowledge to the Nile. Catastrophe 3, the Thera eruption, approximately 1600 BC. If you sail into the modern caldera of Santorini, the harbor at the center of the island, ringed by sheer cliffs of black and red volcanic rock climbing, 300 meters above the water, you are sailing into the throat of one of the most violent eruptions in recorded human history. The cliffs are not natural mountainsides. They are the inner walls of an exploded volcano. The caldera you are floating in is the missing interior of the island, collapsed into the sea approximately 3,600 years ago in an event that ended a civilization. The civilization it ended is the Minoan civilization, the first advanced civilization in European history, predating classical Greece by close to 1,000 years. To understand what happened at Thera, you need to understand who was living in the region first. The Minoans had built something that has no precedent in the European Bronze Age, and very few parallels anywhere in the contemporary world. Based on the island of Crete, about 110 kilometers south of Thera, they controlled a network of palace complexes, trading posts, and cultural outposts spanning the entire eastern Mediterranean. The four great Minoan palaces, Knossos, Phaistos, Malea, and Zakros, were enormous multi-story structures with sophisticated drainage and water management, paved courtyards, ceremonial spaces, storerooms holding agricultural produce in standardized clay jars, and walls decorated with frescoes whose artistic quality would not be matched in Europe for another 1,000 years. The Minoans had their own writing system, actually two of them, called Linear A and Cretan Hieroglyphic, neither of which has been deciphered. They had a maritime trade network reaching Egypt, the Levant, Anatolia, and as far west as Sicily. They were, by every measurable standard, the dominant civilization of the Eastern Mediterranean for several centuries. And on the island of Thera, they had a major outpost. The settlement at Akrotiri on the southern coast of the island was a substantial Minoan town. Multi-story buildings, sophisticated drainage systems, frescoes covering interior walls, storage jars full of barley, oil, and wine. A thriving community. What happened when the volcano detonated was a VEI-7 event, among the most violent volcanic eruptions in recorded human history. The estimated ejected volume was somewhere between 28 and 41 cubic kilometers of material, roughly 4 times the volume of the Krakatoa eruption of 1883. The center of the island collapsed into the sea. Ash from the eruption has been recovered from sediment cores in the Nile Delta, the eastern Mediterranean seabed, and even from ice cores in Greenland, more than 4,000 kilometers away. Here is the remarkable thing. When archaeologists excavated Akrotiri, they did not find what they had expected to find. Unlike Pompeii, Akrotiri contains almost no human remains. The bodies are not there. This means the population was evacuated before the final eruption. The Minoans had received warnings, preliminary seismic activity, smaller precursor eruptions, the kind of ominous geological signals that even a Bronze Age culture would recognize as dangerous. And they had left. They got off the island. Escaping the island, however, did not mean surviving what came next. When a volcano of this magnitude explodes into the sea and a substantial section of an island collapses into deep water, the result is a tsunami. Modern inundation modeling suggests the northern coast of Crete, 110 kilometers south of Thera, was struck by waves that reached heights of up to 28 meters. The Minoan harbors on the northern coast of Crete would have been entirely overwhelmed. The Minoan fleet, which was the operational foundation of their economic and military power, was almost certainly destroyed within hours. This is the moment in most documentaries about the Minoans where the story ends. Volcano, tsunami, civilization destroyed. What most people do not know is that the Minoans survived the eruption. They survived it by roughly 50 years. The clay tablets recovered from Knossos and other major palace sites prove that the Minoan civilization continued to function as a civilization for approximately 2 generations after the Thera eruption. Linear A texts continued to be written. The palace administrations continued to record agricultural inventories. The settlements continued to be occupied. Life went on, but it was a life in slow decline. The sulfur dioxide injected into the stratosphere had dimmed sunlight across the eastern Mediterranean for years. Harvests were reduced. The Minoan economy, which had depended on agricultural surplus and maritime trade, was operating without its full surplus and without its full fleet. The harbor infrastructure had been destroyed by the tsunami and had to be rebuilt with reduced labor. The trade networks contracted. The cultural prestige of the civilization eroded. And on the Greek mainland, a different group of people, the Mycenaeans, who had previously been subordinate to and influenced by the Minoans, were watching. The Mycenaeans had not been hit by the volcano. Their fleets were intact. Their harvests had been less affected. As the Minoan civilization weakened across the decades following the eruption, the Mycenaeans expanded. Sometime in the 15th century BC, roughly 50 years after the Thera eruption, the Minoan palaces were destroyed, most of them by fire. The Linear A script disappeared, replaced by Linear B, used to write Mycenaean Greek. The Minoan language was gone. The Minoan religion fragmented and merged with incoming Greek traditions. A civilization that had thrived for over 1,000 years was consumed by a culture that had been subordinate to it just decades earlier. The cause, traced back through the chain of cause and effect, was a single volcanic eruption that had not even killed most of the people directly. The Thera eruption did not kill the Minoans in one afternoon. It set in motion a slow collapse that played out over a generation. The people inside the collapse may not have understood until the very end that they were inside one. The first European civilization brought down by a volcano whose final act of destruction took 50 years to complete. Catastrophe 2, the 8.2 Kiloyear event, 6,200 BC. The Greenland ice sheet contains the most detailed continuous record of past climate that exists anywhere on Earth. Every year, snow falls on the surface and gets compacted into a thin annual layer. Each annual layer captures, in the chemistry of its trapped water and trapped air, a snapshot of the atmospheric conditions that produced it. Drill cores extracted from the deep ice, 3,000 meters and more below the modern surface, have given paleoclimatologists access to a year-by-year record of global temperature stretching back over 120,000 years. In those cores, at a depth corresponding to approximately 8,200 years ago, there is a sharp downward spike, a sudden, unambiguous cold event. It begins quickly. It lasts roughly 160 years. It ends about as quickly as it began, and it leaves a clear, undeniable signature in the oxygen isotope ratios of the ice. This is the 8.2 Kiloyear event. To understand what happened, we need to go back to North America. When the last great ice sheet, the Laurentide, was retreating at the end of the Pleistocene, it left behind enormous proglacial lakes along its southern margin. The largest of these, Lake Agassiz, covered an area larger than all of the modern Great Lakes combined at its maximum extent, holding an estimated 163,000 cubic kilometers of fresh water. It was dammed by ice. Lake Agassiz merged with a neighboring lake, Lake Ojibwe, forming a single enormous freshwater body covering an area larger than the modern Caspian Sea. And then, approximately 8,200 years ago, the ice dam failed. That entire volume of fresh water, accumulated over millennia, drained into the Labrador Sea. Some estimates suggest the drainage happened in a matter of weeks. Others propose it took several years. The North Atlantic responded the way the ocean always responds, to a sudden injection of fresh water at high latitudes. The Atlantic meridional overturning circulation, the same conveyor belt of warm tropical water that delivers heat to northern Europe, slowed dramatically. With less heat being transported north, temperatures across the North Atlantic and the surrounding continents dropped. The global average temperature decrease has been estimated at 1 to 3 degrees Celsius. But around the North Atlantic itself, in northern Europe, in the Mediterranean basin, in the Near East, the cooling was far more severe. Some regional estimates put the temperature drop at up to 5 degrees. Growing seasons shortened by weeks. Frost dates moved into months that had previously been frost-free. And by 6,200 BC, our species had committed itself to a way of life that depended absolutely on climate consistency. We had become farmers. Across the Fertile Crescent, the Great Arc stretching from the Levant through Mesopotamia to southwestern Anatolia, communities had been practicing agriculture for nearly 4,000 years. They had domesticated wheat, barley, peas, lentils, sheep, goats, and cattle. They had built permanent settlements with mud brick walls and shared storage facilities. They had developed pottery. Some of the earliest substantial towns in human history, Jericho, Çatalhöyük, Tel Aswad, were already old by Neolithic standards. These communities had committed to a way of life that hunter-gatherers had not. They were locked in. Their wealth was in their land, in their stored grain, in their domesticated animals, in their permanent structures. They depended on annual harvests. Annual harvests depended on consistent weather. When the climate broke, the consequences were immediate and severe. The archaeological record across the Near East and southeastern Europe shows clear evidence of sudden settlement abandonment at exactly this period. Sites that had been continuously occupied for centuries were left vacant. Some communities shifted away from grain agriculture and back toward pastoralism. Some moved south into more reliably warm latitudes. Some moved up into higher elevations. In Anatolia, the great early Neolithic site of Çatalhöyük went through significant disruption. Sites in northern Mesopotamia show climate-driven changes in settlement patterns. The crucial lesson of the 8.2 Kiloyear event is not the size of the disaster itself. It is the lesson about who is vulnerable. A glacial-era hunter-gatherer band would have noticed a 1 to 3 degree cooling event, but would have adapted within a single generation by following the game and moving with the climate. A modern industrial city with global supply chains and stored reserves would also adapt, at significant cost, but it would adapt. The communities that were destroyed by the 8.2 Kiloyear event were specifically the early agricultural villages, the people who had bet everything on the assumption that the climate would stay roughly the same from one decade to the next. That assumption was wrong. It had been wrong before. It would be wrong again. The 8.2 Kiloyear event is, in a sense, the prototype for every climate-driven civilizational collapse that has followed. An ice dam failed in central Canada, and farming villages a continent away discovered that the climate had stopped cooperating with their 5,000-year experiment. Catastrophe 1. The 4.2 Kiloyear event, 2200 BC. We have reached the final entry, and before going further, a clarification that the rest of this section depends on. The event we are about to discuss, the 4.2 Kiloyear event, around 2200 BC, is sometimes confused in popular accounts with the Late Bronze Age collapse. They are not the same event. The Late Bronze Age collapse occurred around 1177 BC, that is 1,000 years later. They are completely separate catastrophes with different causes, different victims, and different consequences. With that established, let us set the scene. By 2200 BC, human civilization had been building for 2,000 years. The Neolithic Revolution had given way to the Bronze Age. Cities had emerged, then larger cities, then small kingdoms, then the first true empires. Writing had been invented in multiple places independently. Astronomical observations were being made and recorded. Law codes were being written down. Trade networks reached across thousands of kilometers, connecting tin sources in Afghanistan to bronze foundries in Mesopotamia, ivory from sub-Saharan Africa to workshops in Egypt, lapis lazuli from the mountains of Central Asia to royal tombs along the Mediterranean coast. Three great civilizations dominated the inhabited world. The Akkadian Empire, founded by Sargon of Akkad in the 24th century BC, was the world's first true empire, a unified political entity stretching from the Persian Gulf in the south to the Mediterranean coast in the north, controlling all of Mesopotamia, much of the Levant, and significant parts of Anatolia. By 2200 BC, the Akkadian Empire had been the dominant power in the region for over a century. Its administrative system, its standardized weights and measures, its tax collection apparatus, its road network, all of it was unprecedented in human history. In Northeast Africa, the Old Kingdom of Egypt had been ruling for nearly 1,000 years. The pyramids of Giza, built during the 4th dynasty around 2500 BC, were already over 2 centuries old. The Egyptian state had centralized authority under the pharaohs, organized the construction of monumental architecture on a scale that has never been entirely replicated, and developed the institutional machinery of long-distance governance, taxation, regional administration, irrigation maintenance, that allowed a complex society to function continuously for generations. In the Indus Valley, on the floodplains of the rivers flowing westward across what is now Pakistan and northwestern India, the Indus Valley Civilization, also known as the Harappan Civilization, was at its height. Estimated total population, somewhere between 1 and 5 million people. Cities like Mohenjo-Daro and Harappa had populations in the tens of thousands. The Indus people had a written script that has not yet been deciphered. They had sophisticated urban planning with grid-patterned streets, covered sewage systems, and standardized brick sizes used across hundreds of separate settlements. They traded with Mesopotamia. They had bathhouses, granaries, and what may have been the world's first municipal water supply systems. These were not primitive societies. They had every kind of cultural and technological sophistication that any civilization before the Industrial Revolution would have. And then, almost at the same time, all three of them collapsed. The cause, traced through the speleothem records of caves in Israel and China and Italy, through the marine sediment cores of the Gulf of Oman, through the fossil coral records of the Arabian Sea, through the lake sediments of East Africa, is the same across all of them. The rain stopped. The 4.2 Kiloyear event was a prolonged aridification, a multi-century drought event that affected precipitation patterns simultaneously across the entire planet. It lasted approximately 200 to 300 years. Long enough that the children of the parents who had experienced the first failed harvest grew up in a permanently drier world. Long enough that those children had children of their own who would never know anything else. Speleothem records, the chemistry of cave stalagmites, which form layer by layer from dripping mineral water and preserve a precise record of past precipitation, show the event clearly in cave records on 3 continents. It is one of the most globally synchronous climate events in the entire Holocene record. Now let us walk through each of the 3 civilizations and what happened to them. The Akkadian Empire was the most thoroughly studied of the 3 collapses. In 1993, the archaeologist Harvey Weiss at Yale University published a landmark paper connecting the abrupt abandonment of Tel Leilan, a major urban center in northeastern Syria, to the climate event. Tel Leilan had been a thriving city, population in the tens of thousands, paved streets, multi-story buildings, agricultural surplus filling its storerooms. Then, at the exact period corresponding to the onset of the 4.2 Kiloyear event, the site was simply abandoned. No war, no plague, no conquest. The population left. The desert moved in. Wind-blown dust accumulated over the abandoned streets and continued accumulating for centuries. Across Mesopotamia, the records describe the human response in painful detail. After Akkadian central authority broke down, migrating pastoral populations overran what remained of the empire. The wider regional response to the continuing drought played out across the next several generations. During the Ur-3 period, the recovery dynasty that re-established centralized authority in southern Mesopotamia, the king Shu-Sin oversaw the construction of a 180-kilometer wall between the Tigris and Euphrates. The Repeller of the Amorites, a wall built specifically to control the flow of nomadic population southward. It is one of the earliest known attempts in human history to address climate-driven migration through physical infrastructure. It did not work. The Amorites moved through and around it. Within another century, an Amorite dynasty would be ruling Babylon, and the most famous Amorite king of all, Hammurabi, would issue his law code to a city built by the descendants of the very people the wall had been meant to keep out. In Egypt, the Nile floods, the annual inundation on which all Egyptian agriculture depended, began to fail. The Nile is fed primarily by the Ethiopian highlands, and the failures of the East African monsoon during the 4.2 Kiloyear event reduced the river's flow dramatically. A series of exceptionally low floods is recorded in Egyptian inscriptions after approximately 2150 BC. A regional official named Anktifi left an inscription on his tomb describing the entire south of Egypt dying of hunger, people eating their own children, the strong taking grain from the weak by force, the Nile drying low enough to walk across in places where it should have been a kilometer wide. The centralized Egyptian state, the same state that had built the pyramids of Giza, lost the ability to maintain authority. The pharaoh's tax collectors could not collect from regions that had no harvest to give. Provincial governors began acting as independent rulers. Civil order broke down. What followed is known to historians as the First Intermediate Period, a roughly century-long stretch of political fragmentation that Egyptian later writers would remember as a dark age, a time when the gods had abandoned the land. The Indus Valley Civilization tells the most mysterious story of the three, partly because the Indus script has not been deciphered, and we have no internal accounts of the collapse to read. What the archaeological evidence shows is this: the Ghaggar-Hakra river system, a major Indus tributary, weakened progressively as monsoon patterns shifted. Smaller settlements were abandoned first. The great cities followed, Mohenjo-Daro and Harappa, the two most studied Indus centers, were not destroyed in any kind of violent end. They simply emptied out, layer by layer, over the course of several generations. The standardized weights stopped being used. The script stopped being written. The trade with Mesopotamia ended. By 1900 BC, the entire Indus Valley civilization had effectively ceased to exist as an integrated cultural entity. The population scattered, moved eastward into the Ganges Basin, and over the centuries that followed, merged into the later cultures that would much later become the foundation of historical Indian civilization. But the original Indus people, the people who had built Mohenjo-Daro, who had used standardized brick sizes across an entire subcontinent, who had drained their cities with sewage systems that would not be matched in Europe for 3,000 years, are gone. We do not know what language they spoke. We do not know what they called themselves. We have their ruins, their pottery, their seals, and their undeciphered script. That is all. Here is the part that makes this entry so important. The Akkadians did not know about the Egyptian famine. The Egyptians had no concept of the Indus Valley's collapse. The Indus people, as far as we can tell, did not know that an empire in Mesopotamia was being dismantled by the same climate event that was emptying their own cities. Each civilization experienced its destruction as a local and unique catastrophe, a regional drought, a punishment from gods, a failure of leadership, a curse, an unexplained ecological disaster. None of them understood that the same atmospheric force was dismantling human achievement across the entire inhabited world simultaneously. It would take more than 4,000 years before anyone living on Earth had the scientific tools to recognize that those three collapses were the same event. The civilizations that died inside it died without ever understanding what was killing them. The weight of what remains. Closing reflection. In 2018, the International Commission on Stratigraphy, the body that defines the official subdivisions of geological time, made a remarkable decision. They formally designated the 4.2 Kiloyear event as the boundary marker for the current geological age. The age we are living in now has a name. It is called the Megalayan Age. It began approximately 4,200 years ago. The official scientific definition of the era we inhabit is, in effect, that it started when it stopped raining over the first empires. A specific stalagmite from the Mamlu cave in Meghalaya, in northeastern India, hence the name, was selected as the official global stratotype, the physical reference object against which the boundary is defined. This means something almost shocking when you put it plainly. The current geological age is officially named for a cave formation in India whose chemistry preserves the moment when monsoon failure killed 3 civilizations. There is, in the formal scientific language of geological timekeeping, no clearer statement of how thoroughly human history sits inside climate history. We are not the species that conquered nature. We are the species whose entire recorded existence is bracketed, on its front end, by a drought that ended 3 empires, and that we have scientifically agreed to use as the starting point of our age. 10 eras, 10 worlds the Earth did not keep. A flood so violent that it filled a continent-sized basin in years, and from that flood came the sea, on which the entire arc of classical civilization would later sail. A volcanic explosion that may have reduced our entire species to a few thousand survivors. A continent in the North Sea that drowned by inches over thousands of years and was finished off in a single afternoon by a wave that rose from beneath the seabed off the coast of Norway. A freshwater lake that became a salt sea, possibly within months. And from that rising water came the drowning of the early agricultural communities of southeastern Europe, and perhaps every flood myth from Gilgamesh to Genesis. A climate catastrophe that wiped the megafauna off North America and replaced the first known continental human culture with silence. A green continent that turned, over centuries, into the largest hot desert on the planet, and from that drying came the refugees who helped seed the first dynasties of Egypt. A volcanic eruption that did not destroy a civilization in an afternoon, but set in motion a 50-year decline that consumed it from within. An ice dam in central Canada that failed once and broke the climate of 3 continents for 160 years. And finally, a global drought so synchronized and so devastating that the geological age we are currently living through, the age our civilization is built inside, is officially named after it. There is a temptation, looking at a list like this, to read a kind of secret meaning into it, to find the pattern, to extract the hidden rhythm of catastrophe that supposedly arrives on schedule and erases worlds with grim regularity. That reading is not what this list supports. These events do not arrive on schedule. They are not connected to each other by any single underlying cause. The Zanclean flood and the 4.2 Kiloyear event have nothing to do with each other, except that they both happened on the same planet. There is no countdown clock. There is no pattern. What there is, instead, is something perhaps more disquieting. The mechanisms that produced these disasters, the volcanic chains, the ice sheets that still exist over Greenland and Antarctica, the ocean circulation systems that still distribute heat from the tropics to the higher latitudes. The monsoon patterns that still feed the rains, that grow the crops, that feed billions of people, are all still in operation. Right now, the volcanoes that erupted at Toba and Thera have not been removed from the planet. The magma chambers underneath them have continued to refill in the millennia since. The Colombo volcanic chain, which includes Santorini, is one of the most active volcanic regions in Europe. The Yellowstone supervolcano in the western United States. The Campi Flegrei caldera near Naples. The volcanic system underneath the Indonesian archipelago. All of these are systems capable, in principle, of producing eruptions of catastrophic regional or hemispheric impact. The ice sheets that drained into the North Atlantic 8,200 years ago no longer exist in that configuration. But the Greenland ice sheet is melting. The West Antarctic ice sheet is melting. Both of those processes have the potential, depending on the rates at which they accelerate, to deliver freshwater pulses to the North Atlantic that could affect the AMOC. The geological precedent for what happens when an AMOC disruption coincides with a population that depends on agriculture is on this list. It is the 8.2 Kiloyear event. It is the Younger Dryas. The mechanisms are not different. The atmospheric physics has not changed. And yet, none of these disasters announced themselves to the populations they destroyed. None of them negotiated. The Acadians did not get a memo explaining that the global monsoon system was reconfiguring. The Minoans did not have a seismic warning system that gave them more than a few weeks' notice. The hunter-gatherers of Doggerland did not know that a section of seabed the size of Scotland was about to fail off the coast of Norway. None of them understood until it was finished happening to them that they were inside one of these events. Most of them did not understand it even then. There is a particular cognitive limit that this list reveals, and it is worth naming clearly. Human beings are, in general, quite good at perceiving threats that match templates we have already encountered. A predator, a rival group, a short-term food shortage, a flood that overtops a familiar river. These are the dangers our cognitive machinery was built to track. What we are demonstrably bad at perceiving is slow change distributed across multiple human generations. A monsoon belt that has been weakening for 3 decades. A regional aquifer that has been slowly dropping for a century. A coastline retreating on average by a few millimeters a year for several lifetimes. By the time those processes produce a recognizable crisis, they have already been running for so long that no living person remembers when they started. The Acadians did not see the drought coming because the drought had been intensifying across the lives of their grandparents. The Doggerland communities did not see the drowning of their continent as a single event because no individual member of those communities ever lived through the whole process. The Sahara dried out across roughly 50 human generations. The Indus Valley emptied across about 10. None of these populations were stupid. None of them were uniquely unprepared. They were operating with the same basic cognitive equipment that every population alive today is operating with. They simply could not see, from inside their lifespans, the shape of the change happening to the world around them. There is no obvious reason to think we are exempt from this limitation. The Mediterranean Sea was created by a flood so violent that it dwarfs every war that has ever been fought on its shores. Every map ever drawn of that sea is, in a sense, a map of catastrophe. Every human alive today may carry, in their DNA, the signature of a near-extinction event. The moment when our species came so close to vanishing that we still cannot quite genetically forget it. The pyramids of Egypt may exist only because a lake larger than Germany dried out, and the refugees of a dying continent had to find somewhere else to go. The fact that you exist, that anyone exists to hear these words, depends on a long chain of survival across catastrophes whose scale dwarfs anything in living memory. The world we live in was not given to us. It was left behind. It is what the Earth produced after all of these events finished happening. It is the rubble of the world that came before, recycled into the appearance of permanence. The cities you have lived in are built on the ruins of older cities, which were built on the ruins of older cultures, which were built on places that no longer exist, drowned and dried and frozen, and rewritten by forces that have not, in any meaningful sense, retired. What lasts is not what was strongest. What lasts is what happened to be in a place the catastrophe missed. The mammoth in the Siberian ice was eating buttercups when it died. The Akkadian official, Ankh-Tifi, watched people eat their children. The inhabitants of the last island of Doggerland were standing on a low coastal flat when the sea withdrew, and then returned as a 20-meter wall. None of them knew. None of them the moment before had any sense that the world they were living in was about to be erased. We are no different. We are just the latest version. We have more instruments. We have more knowledge. We know that the volcanoes are still there, and the ice is still melting, and the monsoons are still shifting. We have, on the question of what to do about any of this, the same collection of half-measures and arguments and procrastinations that every civilization on this list also had. 10 worlds gone. The Earth did not announce them. It did not mourn them. It produced them. And it produced what came after. And it is still producing. Whatever is next is still down there. If this journey through the lost worlds beneath our feet found you in the right moment of stillness, if the deep past gave you something to carry into sleep tonight, then consider leaving a comment with the catastrophe that struck you most, the one that made the world feel, just for a moment, less permanent. And if you want to keep going, if you want to know about the late Bronze Age collapse that erased the Hittites and the Mycenaeans together, or about the Carrington event, or about the eruption of Laki in 1783 that killed a quarter of Iceland's population and may have helped trigger the French Revolution, subscribe so you are here when the next one begins. The archive is vast. The silence is waiting. Sleep well.